Hey guys, welcome back to Not Enough Projects. Today we're going to be building the Ford 8.8 rear end for the 72 Nova project. If you guys are also looking to build your own Ford 8.8, I'm going to link some helpful resources I found down below. So let's get to work. Before you start building up the axle, you obviously want it to be very clean. This one's been sitting out for quite a while, so the first step is I'm going to go ahead and pressure wash all the internals out. Try to get most of this gunk clear. I've popped out all the seals and most of the bearings so we can get to everything. So let's get started on that. Alright, it's quite a bit cleaner in here. I'm pretty happy with that. The outside is going to need a good wire brushing to get all the loose rust off. That way we can paint it. But right now I'm just concerned with getting the internals all clean because we still have to weld the spring purchase on. And I want to do that before we paint. Now I'm going to try to dry this off as best I can with the blowgun. And then we'll get this up on the bench and start working on it. Got the rear end up here on the bench. I did go ahead and knock out both the pinion bearing races. Just used a screwdriver and a hammer. There is a little bit of surface rust on the bearing caps and a couple other surfaces. So I think I'm going to go over those with some light sandpaper or Scotch-Brite and see how they clean up. Ran over everything with some light sandpaper. As you can see, it cleaned up pretty decent. I also went over the cover gasket surface. The worst part was the carrier bearing cap surface. These had light rust on them, but they cleaned up okay. There's no deep pits or anything to be worried about. I am going to go run all these bolts through a die and probably run a tap through both the carrier bearing bolt holes and all the cover bolt holes because they're pretty gunked up. Alright, got all the carrier bearing bolts run through the die. These are all 1/2-inch coarse threaded bolts. I'm going to go ahead and run a tap through the bolt holes and then come back and do the cover bolts. Okay, the tap pulled a good bit of junk out of all 4 holes. Ideally you'd be doing this with a thread chaser, but I don't have one for this size, so tap will do. Let's go ahead and do the cover bolts. Okay, all the bolts and bolt holes are clean now. We need to turn our attention to the locker now because it's all rusty, so we need to clean it up so we can get the new bearings pressed on. So here's the Eaton NoSpin locker that's going in. You can see it's got a fair amount of surface rust built up on here. So I'm going to do the same thing, go over it with some light sandpaper, try to get this all off. It doesn't look like it's too deep luckily, so hopefully everything will check out alright. So it seemed to clean up pretty well. I'm only really concerned about the rust on the carrier bearing surface over here and the ring mating surface over here. It's really important that this surface is really clean, and obviously since the bearing has to get pressed on here, you don't want any foreign material in between. I did notice it looks like at some point this locker got dropped or something onto this ring mating surface, so there's a little nick right there and it's actually raised. So I'm probably going to need to sand that down or file it down because you really want this to be totally flat. A little bit more aggressive sandpaper. I think this is 80 grit. So we're going to try just taking the edge off with the burr. Okay, that seems to be pretty good. I can't feel any more bump. As long as it's not raised up, I don't think it's going to be too big of a concern. But if it were raised up, it would prevent the ring from totally seating against the locker here. So that just goes to show you really want to do a thorough inspection on this kind of stuff, especially if you don't know the history of these parts, which I don't. But luckily we got that taken care of. So I might just go over this one more time with the lighter grit sandpaper, just to get the last bit of surface rust on here, especially in this little corner. And then we'll just make sure there's no sanding dust on this. Give the housing one last clean, and then we can get the carrier bearings pressed onto this and go from there. Now that we've got the rust cleaned off of the bearing surfaces and ring gear surface, I'm going to take this over to the press and we're going to press on the carrier bearings. I am going to mark the bearing races so that we keep the race with the bearing that they came with. Okay, we've got it set up on the press. I'm going to press on this lower bearing first. Alright, here we go. We got the other side in. We're set up. Let's go ahead and press them now. Alright, there we are. Now that we've got our carrier bearings on, we can go ahead and get the ring gear onto the locker. Now, like I said earlier, it's very important that the mating surface between the ring gear and the locker or the differential is completely clear of all debris and any raised machining edges or anything like that. Here's our new ring gear. So I'm going to go ahead and just feel for anything that needs filed or sanded down. I can't feel any burrs or any raised areas on this. So I think we're good to just clean everything up. And then we're going to press this on. You're not supposed to draw it in with the bolts, so I'll show you what we'll do. So it's also very important that this mating surface for the ring gear and the locker is completely clean and clear of everything. As you can see, there's a little bit of surface rust, so I'm going to hit this with some light sandpaper, and then we should be good to go. Now that both the shoulder and the mating surface are clean, we can go ahead and continue on. So the Ford instructions say to put a bead of Loctite on the rear face of the ring gear, so we're going to go ahead and do that. I'll also put a little bit on the bolts. Second thought, I applied the Loctite a little too close, a little too far away from the bolt holes. It's not really going to do anything, so I'm going to try to spread it over. Okay, now it should come into contact with the mating surface. So I set the locker in the ring gear like so, and I'm going to bring this up, try to line up the bolt holes. Just get them threaded in. Okay, with all the bolts in, we can go ahead and take this over to the press and get everything squeezed up. Okay, so my press does not have enough capacity to fit the body in between these support bars. So I'm going to try doing something you probably shouldn't do, and which is definitely not the right way to do it, and just stack a bunch of wood. I guess we'll find out. If it doesn't work, at least it'll be entertaining, right? Let me finish getting this set up, and I'll see if this works. No problem at all. I wasn't sure how hard or how tight the fit is between the ring gear and the locker, but it doesn't look like it was a problem at all. So there you go. A little hack for you guys if you have a smaller press like I do. Just stack a whole bunch of old rotten wood. Alright, let's get this out and we'll try torquing all these bolts up to spec. Okay, the torque spec on the differential gear bolts is 97 to 102 foot-pounds. I think we're going to do it in a couple stages, since we got so many of these. First things first, I'll just finger tighten them all down. Alright, the lowest this torque wrench goes to is 30 foot-pounds, so that's where we're going to start. Ideally, you want this in a vise. I don't have one big enough, so we're going to see if I can manhandle it and get them all torqued down. It's not going to be fun, but we'll see. Yeah, I don't think there's any way I'm doing this for 100 foot-pounds. So we'll have to figure something out. Right now we'll do 50 foot-pounds. If I can hold it. Let's go ahead and figure out something to hold this for us, because there's no way I'm going to be able to hold it at 100 foot-pounds. So I'll get back with you guys once I figure something out. Alright, so here's what I came up with. I've got the breaker bar through the axle retainer hole. Not really worried about it damaging anything. The carrier should be harder than it is, and additionally, there's not really tight machining clearances for this thing since it gets bolted in, so I'm really not worried about it. We'll go ahead and get them all torqued down, then we should be good to go. Alright, now we'll do the final torque to 100 foot-pounds. Okay, I'm going to go do one more check. One thing I highly recommend on any job like this where the torque is critical, it's critical that every bolt gets torqued, is use a marker to mark every bolt after you do them to the final torque spec. I usually like to use a red paint marker, but I lost it, so I'm just going to use a Sharpie. Looks like I forgot to check one of them, or mark it at the very least, so that's why this is useful. Go back, double check, even though I'm 99% sure it's already been torqued. Gets rid of any questions. So there we go. With that, our locker should be ready to go. Now we can turn our attention to the pinion. Figured I would add, just in case anybody's wondering, my method of holding it did not cause any damage. Let's see if I can show you guys. There's a slight amount of discoloration, but overall no damage. And the other side, nothing. Although it looks like that does need cleaned up a little bit. So we should be good to continue on. Now that we've got the ring gear and locker all ready to go, we need to get the new pinion races in. I already cleaned up the surface in here, so the race should have no resistance. As you can see, whoever disassembled this rear did not take the greatest care. Hopefully those burrs aren't gonna make a leak. I think there were a couple other nicks. Yeah, that's the one I'm most concerned about. You can see it's a nice deep vertical scar. But I guess we will see. So for now, let's get the pinion race in. We're going to do this outer one first. I'm using this bearing and race installing kit that you can rent from AutoZone or O'Reilly's or whatever auto parts store, I'm sure. So this is the bearing that's going to go up here. So we're just going to take the race, put the bearing aside, find which one of these fits the race right. Here we go. Set you guys up. And you can see this one's been well used, that's for sure. Should still work just fine for us though. Then we just tap it home. That feels like it went. Yep. Now we're driven all the way in. I could tell because it felt a little bit different and it also sounded a little bit different. And you can see there's this little lip machined, and the top of the race is flush with that. So now this bearing fits in there perfect. But we're going to leave it out for now because we got to flip the housing back over and get the inner race installed. Alright, I went ahead and got everything nice and clean in here. So now we'll get the race for this bearing here. Find the driver we need. Let's see. A little small. That one's a little too big. I don't want to drive it in like that because, as you can see, it's going to potentially mar up the inner surface of the race. So I think we'll do this backwards. That should be okay. It's just going to be a little bit more tricky to get it square into the bore. But we will give it a go. I've gone ahead and flipped the housing up on end like this, so that gravity's working with us to drive the race in. Let me get you guys set up and we'll start pounding it in. This one's a little bit more awkward since it's inside the housing, and the end of the driver doesn't really stick out of the housing, so I can't hold it very well. But we will see what happens. Seems to be going in okay. It's going a little crooked now. We might need to whack it back out and retry. Well, let's see if I can readjust a little bit by... Let me show you guys what I can see. Hope you can tell, it's cocked to this side a little bit. Probably the best thing is to knock it out. I'm going to give it just a couple more whacks, see if I can get this end down. I'll favor it a little bit with the driver. If not, we'll just pound it back out, no big deal, and go from there. Well, I think I'm going to go ahead and drive it back out. It's not really getting much better, and I don't want to get it cocked in there too hard. So let's flip it back over and pound it back out this way. Alright, got the race pounded back out. It's still healthy. So I'll make sure everything's clean. And then we'll give it another go. Okay, looks pretty square to me. Alright, here we go. Yep, looks like it's going in square. Give it a couple more whacks. Feels like it's seated in there all the way. You could hear the sound change a little bit once it bottomed out. And it looks like it's flush with the little machined radius here. So I think we're going to call that good. You can see how much easier it goes in when you get it on straight. With it cocked like that, I would have had to really pound it on it to get it to keep going, which you don't want to do because you'll distort the bearing race. But with both of those in, we're ready to get to the fun part, or not so fun part, of setting the pinion depth, which is the real meat of building one of these. So let's get to it. So given that I got this axle housing completely empty, I have no shims, no factory shims to go off of for the pinion depth. Now 29 to 30 thousandths seems to be a relatively decent starting point on these Ford 8.8s. So I've got a stack of shims here that's about 29 thousandths. It's always a little hard to measure them. So I'm going to put that on under the bearing, and then we're going to need to press this on. And hopefully we need to remove this bearing as few times as possible to change the shims, because it's kind of a pain because you got to split the bearing off and press it off. Now I know some guys will get 2 new bearings and shave the inner diameter of one so that it slides up on and off easily, and that's a great way to go, but I only have this one bearing, so it is what it is. Let's go press this on and then we can see how it goes. Okay, I've got the new bearing set in the old race just so it's supported while we press. I'm going to make sure the surface is nice and clean. Set the pinion in. And it looks like we're going to have to adjust our depth here. So let me do that real quick. Okay, we've got it readjusted in the press. We should be good to go. It's not hanging up, it's going in real easy. So that's what you want it to be like. Okay, that's bottomed out. Let's release the pressure. Still spins nice and free. Perfect. Before we get too far getting everything into the case, I'm going to give it a little bit of blowgun action just to get any debris that might have fallen in there out. Alright, it's much better. I'm happy with it now, so let's go ahead and get the pinion in and try to get the pinion depth set. So now let's get our pinion in. I should have mentioned earlier, this is a 308 gear set. It's not really anything too radical, but since this car is getting a TH350 transmission, which doesn't have an overdrive, we're wanting something that's a little bit more street friendly, you know, can handle some use on the highway and whatnot. So that's why I went with 308, and the 454 is so much torque, it's not going to be a big deal at all. It's going to be more than good enough. So, at least initially, I'm going to try installing the pinion without the crush sleeve and with no seal or oil slinger or anything like that, because I'm not worried about the pinion bearing preload right now. That's what the crush sleeve sets. It sets how much preload is on the bearings, and you check it with your inch-pound torque meter. Right now, all I'm worried about is how the pinion and the ring gear mesh, which is a function of the pinion depth. So I'm going to leave those out because the crush sleeve is one-time use, and it's also really a pain in the butt to get it to collapse. Here's our new yoke. So I'm going to get the outer pinion bearing in onto the shaft, and then we're going to get the yoke on here, and then get the nut tightened down on the yoke. Here's the outer pinion bearing. we're going to put that on over, get it into its race. I think I'm going to try to turn the axle sideways so we can get better access at this. Okay, there we are. Now we can kind of get in a little bit better. Okay, so I found that the outer pinion bearing, the fit is too tight. It won't slide down to where it needs to go, and I can't even get the threads started really. So, you see, yeah, that goes. I'm going to take a bit of really light sandpaper and just scuff the coating off of the surface so that it's a little bit less tight and we can get the nut started and the bearing slid down on there. Okay, you can see I'm starting to take the coating off. I'm going to give that a test fit and see if it gets us there. So it's still not sliding all the way down, but there's now enough thread sticking up that we can get this nut threaded on. So we should be able to pull the bearing in with the nut. So let's get the pinion set back into the housing, get the bearing set in there, and get everything pulled together. Okay, the pinion is set in. Next we're going to do the bearing. There we go. Actually need to prop up the housing. Got an 1 1/16 socket. Starting to get tight, so I'm going to go grab the pinion holding tool. So here's our pinion yoke wrench. You can see it's just a plate of steel with some holes cut in it. It's got a place for a 1/2 inch drive breaker bar and looks like a 3/4 inch drive breaker bar. And a bunch of holes cut in it too. Except a bunch of different yokes. That's awesome. Apparently does not fit ours. Or at least not very well. You just have to use these tiny bolts, I guess. Maybe it'll work. Let's see if we can make something line up here. And there's no hole for the 4th one. It doesn't look like. But 3 out of 4 is pretty good, right? Maybe it'll hold it. Guess we're gonna find out. Okay, I got another 1/2 inch drive ratchet. Gonna need an extension. We're not doing the crush sleeve right now, so the only resistance is just pulling that bearing onto the pinion shaft, which shouldn't be that much. Okay, it's pretty tight. Oh, yep. All of the play is taken up right now, and I'm not concerned with the preload because we're going to be coming back. This thing's coming out again because we got to get all the seals in the crush sleeve. But all the slack is taken up, which is all that I was wanting to do. Now we can get the carrier in and check the gear mesh pattern. So now that we've got the pinion installed and bearing preloaded, not to spec, but enough that we should be able to figure out the depth, no problem. We need to install the carrier and figure out what shims need to go on each side. So according to the Ford instructions, you should start with 265 thousandths worth of shim on the left hand side. So I'm going to make a shim pack out of this group of shims. That's that width. Here you can see I've got a shim pack. A little tricky to measure because there's oil and stuff in between. That's about 265 thousandths. So we'll install that with the carrier onto the left hand side. Okay, we've got our shim pack here for the left hand side. And we got the bearing race. Shim pack goes on the outside of the bearing race, obviously. Let me readjust you guys so you get a better view. Okay, I've got the shim pack and bearing race in my hand over here. I'm just gonna hold it on like so. And the other side's bearing race. And now just heft it into place. Okay, I'll get this bearing cap just loosely on here. So as you can see, the race is not fully seated into the bearing, so I'm going to use a screwdriver to just gently push it over. There we go. Turns out my hand worked better. Just use the screwdriver to make sure it's fully seated. Just going to lightly snug this up. So now, since we're working with a case that I got empty, I have no idea what shims it had from the factory. We're going to shove whatever shims we can get in here by hand only, and then we're going to set the case spread by adding a couple extra shims on each side. So the shim kit I have came with this shim, which you can see has a lip on it for other shims to get onto, and then this other thick shim, that's the backing plate for the rest of the shims. So I'm going to start just with that and see if we can get that fully in by hand. Yep, seems like we can. So let's add a thin shim to this stack. I think I'll go with one of the thicker, mildly thick shims. Let's see if we can fit another small, the thinnest one I have in. Seems like that's going to be the max amount I can get in by hand. Just make sure everything's fully seated. Give it one more go. Nope. Okay, so these shims are what we can get in by hand. So now we're going to add 6/1000ths to each side just to preload the bearings, make them a little tight. So I'm finding there's one issue I'm running into where if I put pressure on this bearing cap, you can see basically stops it from spinning. But while it's loose, it spins just fine. So I'm going to pop this off and see what's hanging up. You know what? I'm wondering if I didn't seat the rear pinion bearing in all the way. It felt like it was tight, but it's a press fit, so I think I might need to go even tighter on it. Let's try doing that and see what that brings us. So after doing a little bit of looking, our issue was the shim pack was too thick on this side. So it was not allowing enough clearance between the ring gear and the pinion. So there was no backlash. I took all the shims in between these two caps, moved them over to this side, and as you can see, it moves now. It seems a little thin on this side, but this is an aftermarket ring and pinion. So the Ford instructions and the Ford measurements are probably going to be off a little bit. But it could also be that our pinion depth is wildly wrong, which is what I kind of expect. Okay, so now that we got the problem figured out why it was binding up, I'm going to add 6/1000ths worth of shim to each side for a total preload of 12/1000ths. Since it's tight, I'm going to use the shim driver. And a hammer. There we go, fully seated. There's basically no backlash, so we're going to need to adjust. But I am going to just tighten this cap up, just to make sure that's not going to affect anything. That feels like way too little backlash. But let's check with the dial indicator. There is no backlash at all. So, we need to move a shim from this side and put it onto that side. That'll push the ring gear this way and make it mesh less with the pinion gear. So we'll go ahead and take the bearing caps off. We're actually just going to loosen up the bolts for now, because since the bearings are preloaded, it's a pretty tight fit into the case, so we're probably going to need to use a pry bar. and I don't want it rolling all the way out. So the bearing cap should be able to catch it. I'll try starting with a little guy. Nope. We're gonna need two, I think. So I've got the axle housing on the front of the table so that I can get two pry bars in here. Oops. And just work it out, just like that. Okay, bearing caps are off. I'm going to scoot this back so that if it does fall out, it'll fall out onto the table. Okay, so I'm going to take this little shim I had here on the left side, put it into the shim pack on the right side. And now we should be good to go. Okay, shims are fully seated. Let's get the bearing cap on there. Certainly feels better. I don't know if we have quite enough yet though. Okay, let's measure it up. Okay, the backlash seems to be close enough that we can check the pinion depth now. To do that, since I don't have an actual measuring jig that goes into the center line of the axles and measures the depth, we're going to use gear paint and see how the gear mesh pattern looks. So here we've got some gear paint, just need to cut off the nozzle. We got a little brush. So now we're just going to spin this back. Okay, now we can go ahead and check our pattern. Here's our new contact pattern. Still looks to be centered decently. So from my understanding, it's pretty normal for the coast side marking to be towards the toe a little bit, which is what we're seeing here. And this is centered, you know, from heel to toe pretty well. My understanding, and I'm no expert, but my understanding is that the centering from heel to toe is not as big of a deal as centering from the top or the inner to the outer side. Which you can see it seems to be doing okay. But I think we're going to adjust the backlash and then take another reading and see where we're at. So I think we're going to try moving just one of the smallest shims on the right side to the left hand side. See if we can get a little bit more out of it. Now we just want to make sure the shims all stay together. Let's move the housing back a little bit. We need to take the thinnest shim we have over here. Let's measure the overall thickness of shims we have going on. So now on the left hand side we have 224 thousandths. And on the right hand side we have 307 thousandths or so. So now that we've got this shim moved over, we just do it again. You want the chamfered shim on that side. And drive it on home. So the camera died. You didn't miss anything too exciting. All I did was move the thinnest shim from the right hand side to the left hand side. And then I tightened all these bolts down to 90 foot-pounds. The spec is 90 to 100 foot-pounds. And now I'm checking the backlash. Alright, so here's our gear contact pattern. You can see both sides, both the drive and coast side, have a pretty sharp edge, which you don't want, and it doesn't seem to spread out like you want to see. So this suggests to me that the pinion depth is too large, or too little, so the pinion is too far forward. So we're going to try pressing the pinion back out, pressing the bearing off, and then we're going to reduce the shim by, I don't know, we'll see what the thinnest shim we can do is, but hopefully around 1/6 thou or so. Alright, I've got the pinion driven out. I just took off the yoke and just used a hammer to knock it out as gentle as I could, since this bearing's pretty tight fit. So now we're going to try to put the bearing splitter on it. We want to get it under the inner race. You don't want to press on the cage. So let's take it over to the press and see if we can get it off. So here's how I've got it set up in the press. You just tighten up the splitter halves onto the bottom of the bearing. You can rent these at AutoZone or O'Reilly's or any auto parts store for cheap. My press isn't wide enough to actually fit the pinion gear through, so that's why I'm going to try stacking it on these wood blocks. I don't really know how it's going to turn out. Worst case, we're going to need to stack some steel. But let me get you guys set up and then we'll press it off. We're going to have to readjust to see the gear hitting one of the supports I have on here. Okay, should be good now. And there it goes. See the bearings unharmed. Set the splitter over here. And now we can access our shims. So here's the shim stack we had on the pinion before. As you can see, we have about 29 thousandths worth of shims. I'm going to try taking out this one, which is worth about 5 thousandths. So we just now have these two shims, which have a total thickness of about 21 thousandths or so. So let's get these back on there and press the bearing back on. Okay, here we got it set up in the press. Let's go ahead and drive it back down. Okay, there we are, bottomed out. And there we go. Now that we've got the thinner shim stack pressed on, let's get this back in the housing and try it again. Okay, so now I'm going to put the pinion back in just like last time. I'm going to leave the seal out and the crush sleeve out because we don't need to set the preload exactly right now. We're just checking the mesh pattern. So let's get this set in. Get the rear bearing slid on. So now I'm just going to draw the outer bearing in by tightening the yoke nut. Now I'm going for a little bit more preload than you probably want with final assembly, just because I want to make sure all the slack is taken up and it's not really going to affect our readings. Plus it makes it so it's easy to check backlash with a real tight. Okay, now we're ready to get our carrier back in, making sure to keep the shims in their original position. I'm going to go ahead and get this left bearing cap loosely on there. Not too worried about full torque spec right now because we're not really worried about the bolt stretch, because we're not worried about the bolts backing out since we're not running it. I just want to make sure the bearing caps are fully seated, and then we won't have any problems getting an accurate measurement. Let's go ahead and check our backlash, because we want to make sure that's correct before we do a gear pattern check. Okay, now we're set up to check our backlash. We're at about 13 thousandths of backlash, which is just a little bit out of spec. I don't know if we're going to be able to take that up without going too far, so let's just take a quick gear contact pattern, and based off of that we can try tightening up the backlash a little bit. So we're just going to do the same gear painting on a new section. Now I'm not sure if I mentioned this earlier, but the way they do it at the factory and the way an actual differential shop would do it is they have a special tool that's basically like a dummy carrier, and it goes in between here, bolts into the bearing caps, and it allows you to check the pinion depth numerically. And aftermarket gear sets have written on the head of the pinion a checking depth, which is what the manufacturer determined was the best depth for the pinion. So if you have that tool, which is expensive, I think it's like $800 or so, then you can set this up in like 15 minutes. There's no guessing. You just bolt the tool up, put the pinion in, set the depth, and then you're good to go. But I don't have the tool, so that's why we're doing this. And I doubt many of you guys have the tool or want to spend the $800 for the tool. So this is the other way you can do it. It's a little bit more tedious and it's a lot more subjective, which can make it tricky, but you can still get good results. Okay, now let's give that a few revolutions. I'm going to preload the pinion just a little bit. Alright, now we just need to find our new marking. I believe it was this one. Keep my hands cleaned up and I'll show you guys what we're seeing. Here's the drive side. You can see it's looking a little bit better. Especially on the coast side, it's a little bit more spread out. There's still a pretty sharp line though, which you don't really want. It's not desirable. Centering wise, it does seem to be decently centered. Okay, based on that pattern, I think I'm going to go ahead and try decreasing the backlash a little bit. So move the thinnest shim from here to here and see where that puts us. Okay, so now what we're going to do is we're going to take the thinnest shim from this stack, move it on over here, and reinstall. Definitely tightened up. Let's see where we're at now. Well, we're right about at 8, maybe a touch over 8. So that's within spec. Let's go ahead and check the pattern now. Just gonna add a touch more paint. Might even just be able to respread what we just used. Just gonna add a mark here so no. Okay, let's give that a go. Let me show you guys what we're working with. Okay, so after looking at some charts from Ford Racing and Yukon Gear, I think the pinion depth is correct, because my understanding is that pinion depth adjustments would make the two marks go opposite of each other. And if you look here, the coast and the drive appear to be right in line with each other, and our backlash appears to be right. And you can see the pattern is pretty well centered from the root to the face on both the drive and coast side. Apparently it's not that big of a deal for it to be not centered this way on the gear from in to out, because you can see this is a little biased towards the toe. And that sharp line I was a little concerned about, but after some reading, I've read a lot of guys have also had the same experience as me, and you can't really get rid of it, and it's not actually a big deal. So I think we're going to run this and see how it goes. Now again, I am no expert. I'm sure there's a lot of you guys with a lot more experience on these than me, so feel free to tell me how big of a mistake I'm making, but I think it's going to be okay. So we're going to double check the backlash, and then we should be good for final assembly. Okay, so now that we have everything blueprinted, we can go ahead and get the pinion in for real and set the pinion preload. So the first thing we're going to need to do is get our bearing and seal put in. First things first, we're going to set in our bearing. I'm going to go grab some gear oil so we can pre-lube it. Okay, next up, we have this little spacer. I need to go clean it up and then we'll get it done. Okay, we've got the oil singer cleaned up. Set that in. Then next up comes the seal. I'm actually going to put a bead of RTV around the outer ring of the seal, since we have the marring on the case, just to give us the best chance. Alright, I'm going to use some of this Permatex Right stuff. I've had good luck with it in the past. So I'm just going to apply a light skim coat along the edge. Okay, that should be good. set this in place. Wipe my hands off. Alright, I don't have a socket or a driver big enough to fit around this, and since it has the lip that sticks out, you can't just use a 2x4. So I'm just going to tap lightly around the edge with the dead blow. As you can see, it's a little fiddly, but you just got to work around it. Eventually you'll get there. Okay, it's seated evenly all the way around. So now we should be able to get the pinion in. Before we get too far on that, I am going to pre-lube the seal. Never really want to install any seal dry. Here's our pinion. You can see I installed the crush sleeve onto it. So now we just need to go up through the bottom, get the yoke on, get the nut on, and then we can collapse the crush sleeve to the desired pinion preload. Okay, we've got the nut threaded on. Let's start drawing them together. Okay, I've got our holding plate on here. I think first things first, you see how much play is in there. I think I'm going to run the nut down as far as I can with the impact, just to make things easier on us. Once we get close, we're going to change to a breaker bar. Okay, we just about have all the slack taken up. I may have gone a little far, but it doesn't feel like we have that much preload on it yet, so that's good. What we're going to need is our inch-pounds torque wrench. It needs to be either a beam style like this or a dial style. The dial torque wrench is a little bit nicer to have in this situation because it's easier to read, but the beam style works just as well, and it's like a quarter the cost. So that's what I got. Okay, so I've got my stack of adapters to get it down to 1/4 inch. And we're just going to put it up here. See how much it takes. We're at about 2 inch-pounds right now. The spec for new bearings is 16 to 28 inch-pounds. The spec for old bearings is 8 to 14 inch-pounds. So we still have a little ways to go. Now with the crush sleeve, you can't back it off. So if you go past the correct preload, if it gets too tight, then you need to get a new crush sleeve. So we're going to do this in pretty small increments. I might need to go grab a pipe to keep this ratchet from spinning, because these get pretty dang tight. Yeah, I need to go grab a pipe. So I'll be right back. Alright, I got my pipe here. So we're going to see if we can get it to tighten up. Oh man. Oh man. Very tight. Got it to move a little bit. Like I said, you want to sneak up on it because there's no going back once you go past. You know, we got a long ways to go. I think I'm going to need to go find another pipe to put over my breaker bar so we can get this done. Okay, I've got another section of pipe. Let's see if we can get it down. A little bit more. I doubt we're even close. I think I'm going to try hitting it with the impact, just at real low speed. See if I can get it to turn a 1/4 turn or so, and we'll check it. That wasn't even really touching it. It only turned a tiny, tiny bit. So I think we're gonna. Whoop. I think we're gonna need to just get a bigger pipe. I got it a little bit tighter. We're at. Well, that just goes to show you how close you got to creep up on it. Now we're at. 14 inch-pounds or so. So we just need to give it a little bit of a nudge, and then we should be good within spec. Now we're right around 22 foot-pounds. 22, 24. It's right around where we want to be. I'll get the camera up here so you guys can see the dial. A little tricky to do, to film and do this at the same time. So you can see we're sitting right around the mid-20 range, so we should be good on pinion preload. Now that we've got the pinion bearing preload set, we can move on to getting the carrier back into the housing for good. I'm going to go ahead and oil up these bolts, just a light amount of oil so that we get the proper torque spec. And if I didn't mention this earlier, the caps need to stay on the side they came out of, and you can see these triangle marks. They point towards the end of the axle. Now that those are set in, we'll get the right hand side bearing cap on. Let's get both sides snugged up and then we'll double check our backlash reading. And for a good measure, we'll do one more gear contact measurement with the paint. So we're right at 7 thousandths, which is actually out of spec according to Ford Racing. But according to Motive Gear, who made the ring and pinion kit, they designed their gears to run at 7 to 9 thousandths. So we're within spec there. Let me show you guys the reading I'm seeing. So you can see I've got it just about zeroed. Go ahead and rock the ring there. And you can see we're right at 7 thou. Now we're going to go ahead and tighten down the bearing caps to spec. The Ford torque spec is 90 to 100 foot-pounds. So we're going to do 95. Let's check the gear contact one last time. I'm going to mark right here just so we know. That's the one we just did. Let's go ahead and spin it around. So here's the contact pattern. It's pretty faint on here, but it is very similar to what we saw before, and I think we're going to roll with it. Like I said, I am not an expert at this. From the best of my knowledge, I've done a lot of reading, a lot of research. This should be okay, but again, I'm no expert. Do your own research and set your rear up how you want to set it up. Alright, now that we've got the internals of the differential pretty much buttoned up, I'm going to go ahead and get the cover on so we can take this outside, sand down the outside, cut off the shock brackets that we no longer need, and then we can get a coat of paint on this thing. One unfortunate design of this locker that I noticed is you can't get the pin that holds the axle retainer in with the bearing cap on there. So during final install, we're going to need to pop the bearing cap back out so we can get this retaining bolt back in. But for now, that's no big deal. So let's get to it. Alright, the new cover is on. I think this is a Summit Racing branded chrome cover for this. And one annoying thing is that the bolts it came with are just a hair too long, so they actually bottom out before they actually put any tension on the case. So for now, I just threw in a couple washers so we can get the cover snug. We're either going to need to get new hardware for this or cut the bolts down or something. I think I'm going to cover this up with masking tape mostly so I can protect the nice chrome surface. And then we'll take this outside and get to cutting and grinding. Alright, got the housing outside. I'm going to stuff a couple rags in the ends of the housing just to keep any gunk out. So let's get to it. Alright, so I got the axle housing all cleaned up. I figure before I paint it, I will get it mocked back up in the car so that we can weld the spring perches on without having to clean the paint off. So I think I'm going to call it for this episode. We made a lot of progress. We got the rear end built. Next time we'll be getting this mocked back up in the car, set the pinion angle, get the spring perches welded on, get it painted, and check out the driveline. If you're enjoying this project so far, I'd really appreciate it if you subscribe. You can get the notification for when the next episode is out. Give this video a thumbs up if you enjoyed, and I'll see you guys next time.